Hi everyone, welcome to KTU Web. In this video, we are going to discuss about efficiency of riveted joint. So far, we uploaded two videos regarding riveted joint, and in those videos, we discuss what are the types of riveted joint and what are the major modes of failure that are oftenly found with riveted joint. If you didn't watch those two videos, I am advising you to do so. That help you to understand this topic in a better way. Okay, let us discuss about efficiency of riveted joints. Most of the time when we calculate efficiency of a machine or a machine component or whatever the case, it will give you a numerical value which give a basic understanding how much output it can generate with respect to maximum possible output what we are expecting from that machine or component. Okay, let us calculate efficiency of this particular joint which support a tensile load by using these two rivets, and the whole efficiency depends upon a single unit of rivet. Here the single unit of rivet means the rivet that connect apart a pitch length P. So this is the pitch length P, and we are setting up two rivet at a distance of pitch length P. Every time when you want to find efficiency equal to the strength divided by maximum possible strength. Okay, let us ask the strength of riveted joint means how much force this riveted joint can withstand. But what will be the maximum possible strength of this particular joint? Theoretically speaking, this particular thing will get maximum possible strength when it become a single unit. Suppose we removed these two rivets from this joint and we are assuming this as a single unit. So instead of riveting these things together, we believe that this thing is a single piece of solid plate. Suppose it's a single plate with a homogeneous material, it can give the maximum possible strength. That means the maximum possible capacity that you can manipulate with this plate will be equal to the strength of that solid plate without rivet. So here on denominator, the maximum possible strength means the strength of solid plates is the maximum possible strength that you can expect in a riveted joint. Okay, let us discuss about these two factors. If you have the strength of riveted joint and the strength of solid plate, you could have this ratio and that will give you the efficiency, and we oftenly denote efficiency in terms of eta. So eta can pretty much simply find out with this relationship. Now we have to discuss about the strength of rivet joint as well as the strength of solid plate. Okay, initially we can go for the strength of solid plate. The strength of solid plate means suppose you have this particular piece of solid plate and it upon application of some tensile load it may break, and that is what happen upon failure. The strength means the maximum force it can withstand on its cross-sectional area. So I am going to consider the cross-sectional area of this plate. Here the length will be the pitch P and this will be the thickness T of that plate, and the cross-sectional area that you can easily write, this area is equal to pitch P into thickness T. So when you want to calculate the strength of a solid plate or how much force it can withstand, that is what basically strength. So we know that the stress is equal to force by area, and the stress means how much stress that it generates. We denote it as sigma T is equal to force by area. What is area here? P into T. Here the term force simply, so the strength of solid plate is equal to sigma T into P into T. So remember, we will be using this equation to find the strength of solid plate. So all the time we will be putting this value on denominator. Now we have to find the strength of a riveted joint. When it comes to strength of riveted joint, there is different scenarios and situation where we find the strength of rivet. The strength will be calculated based on the three basic modes of failure. The first one, you remember when the plate tears, as we discussed in previous video. The strength of tearing of plate can be calculated as PT, that T stand for tearing situation. PT is equal to pitch P minus D into sigma T into thickness T. So this equation gives you the strength or the tearing strength of the plate. Now we can calculate the tearing efficiency eta T is equal to PT by the strength of solid plate. That means P minus D into sigma T into T divided by, as we know, P is equal to sigma T into pitch P into T. We can solve this equation and little bit arrangement. Sigma T we can omit, and thickness T. We can write the tearing efficiency is equal to P minus D by P. So this is the equation for tearing efficiency of rivet. In the similar way, we can also calculate the efficiency when the failure situation like shearing of rivet. So the second category is shearing of rivet. The strength of shearing of rivet, what we derived in previous video, PS is equal to pi d square by 4 into 2. So this equation what we used for single shear. Hope you remember this case of single shear. You could see in this lap joint we have only one shear surface, but in case of this double strap butt joint, we have a shear area right here, another shear area right here. So in this condition we have double shear. In those cases we can write PS is equal to 2 into what you have in single shear, that is pi d square by 4 into tau. So this equation stands for double shear. And hope you remember this IBR standard equation. According to Indian Industrial Standard or Indian Boiler Regulatory Act, you don't need to consider 2 times of shear area. Instead of that, you can take PS is equal to 1.875 times of single shear, that is into pi d square 4 into 2. And remember, for any standard design we will be using this as a standard equation for shear. Instead of 2 we will be using 1.875. And here there is another consideration. Whenever you design a rivet, you have to identify how many rivets are there for single shear and how many rivets are there experiencing double shear. Suppose you have N1 number of rivets with single shear and N2 number of rivet with double shear. Now the strength of a single shear that we can write, PS is equal to N1 into pi d square by 4 into 2. There is N1 number of rivet, so N1 into what you have the capacity for a single rivet. And for a double rivet, PS is equal to, suppose there is N2 number of double rivets shears are there, that is N2 into, we'll be using standard equation, that is 1.875 into pi d square by 4 into tau. So this will be the strength of single shear, this will be the strength of a double shear. Suppose that joint contains both single and double shear, the total strength that we can add these equations together, PS, is equal to combining these two equations together, general equation for shear as PS is equal to, adding these two values together, N1 plus 1.875 N2 into pi d square by 4 into 2. And hope you remember, this is the basic general equation for a rivet with a single shear as well as double shear. Suppose you have a joint that offer both kind of rivet, you can use this equation. Suppose there is no double shear, automatically this N2 becomes 0 and you can avoid that term, and vice versa. And this expression give you the strength of rivet when we considering the shearing of a rivet. We can calculate the shearing efficiency of rivet. We denote it as eta S is equal to shearing strength divided by the strength of plate. That is the shearing strength, what we call PS, divided by the strength of solid plate, P. So basically it give you eta S is equal to all divided by the P value. Hope you remember the P value what we have. So this is an expression. It will be available with most of the standard data books. You can use this expression to find the shearing efficiency of any rivets. Hope you remember from my previous video, the third case was crushing of rivet or crushing of plate. We already derived an expression to find the strength of this failure situation. The strength what we denoted as PC, that C stand for crushing, PC is equal to sigma C into diameter D into thickness T. So this is the expression for finding out strength when crushing occurs. As same as in the previous case, suppose you have N1 number of rivet with a double shear. Hope you remember the number of rivet with double shear will be equal to the double crushing condition. If there is rivet with under double shear, definitely it will be under double crushing as well. So suppose N1 is number of rivet with single shear and N2 is equal to number of rivet with a double shear. And you have to remember the number of double shear will be equal to the rivet with the double side crush as well, and the number of shear with the single shear will be equal to the number of rivet with the single crushing as well. Now we can find the strength of each type of rivets. Strength of single shear rivet. Here we have two kind of plate, one master plate and one cover plate. For the master plate we will take a thickness as T. For the cover plate we will take thickness as Ti. So single shear, you have to consider the shear of the cover plate. So PC of single shear is equal to N1 into sigma C into D into T is the thickness of cover plate, that is Ti. Then the strength of double shear rivet is equal to PC. So there is N2 number of double shear rivet, N2 into sigma C into D into, instead of T inner we will use the thickness of master plate, that is into T. So the total strength will be addition of these two values, N1 sigma C into T plus N2 sigma C. We can arrange this equation a little bit. N1 T of cover plate plus N2 into T of main plate. This will be the expression of crushing strength of any standard rivet. If you have the crushing strength, you can write easily the efficiency, the crushing efficiency, all divided by the strength of solid plate, that is pitch P into thickness into sigma T. We can use this expression to find out the crushing efficiency of any rivet. Okay, let us conclude this efficiency equation. So far we found three different types of efficiencies. First one is the tearing efficiency. T is equal to PT by the efficiency of solid plate. And the second one was shearing efficiency, that is eta S is equal to shearing strength by the strength of solid plate. The third one is crushing efficiency, eta C, that is crushing strength by the strength of solid plate. We have these three efficiencies: the tearing efficiency eta T, shearing efficiency eta S, and last the crushing efficiency eta C. So the efficiency of joint will be the least of this value, eta T, eta S, and eta C. That suppose for an example you have eta T is equal to 75% and eta S is equal to 85% and eta C equal to some 72%. When you have to find the efficiency of the joint, you have to find these three and finalize eta C as the efficiency of that joint. So this will be the joint's efficiency. Here the catch of this video: there is three different types of efficiency for each and every modes of failure, named as eta T, eta S, and eta C. We have to find these three efficiencies, and at last we will choose the least among these three and we set it as the joint efficiency. So why we are taking the least value? Because when the system failed upon crushing, there is no matter how much more efficient that there in the shear or that there in the tear. So we have to consider the least situation whenever you design the riveted joint. Hope you understood this topic. I will put the link in description to download my note regarding this video. You can learn from that note as well. As always, thank you for watching. I will coming up with new videos.